So hello everyone. Today I'm back again. My end sim was going on, so I was little bit busy and I was not able to upload any video in that time. So now we are going to solve like today's daily LeetCode problem. So let's go to the LeetCode and you will find the daily problem here at the top right corner, the fire icon. If I click this, let's see what is today's problem. First, let me do the full screen. Okay. So today's problem is problem number 31661, block placement queries. Okay, so basically, let's read the problem. It's a hard problem. There exists an infinite number line with its origin at 0 and extending towards the positive x-axis. Okay, basically, we have a number line. You are given a 2D array queries which contains two type of queries. One for a query of type 1 queries I is 1x. So basically, first type of query is 1x, build an obstacle at distance x from the origin. It is guaranteed that there is no obstacle at distance x when the query is asked. Okay. For a query of type 2, query I is 2, x, size, check if it is possible to place a block of size anywhere in the range 0 to x on the line such that the block entirely lies in the range 0x and a block cannot be placed if it is intersect with any obstacle, but it may touch it. Okay. Note that you do not actually place the block. Queries are separate. Okay. So basically, there are two types of query. First query is type of 1 comma x. We have to make an obstacle at coordinate x. Basically at the distance x from origin, from query to 2 comma x comma size, we have to check that if it is possible to place a block of size anywhere in the range 0 to x. We don't have to place that. Basically, we just have to tell yes or no that we can place or not. Like we have to find if there are sufficient place for this block. So return a Boolean array result where result I is true if you can place it or otherwise. And the queries are separate means for current query, like if you are asked to if we can place a block or not, we have to just return yes, no. We are not going to place the block there. Okay. So in the first example, if you see 1, 2 means there was a number line. Let me open the OneNote to make this understand. So here we are given that we are provided a number line. So let's draw this is origin. Now we have 1, 2, 3, 4, 5, 6. I think this is good. Now first query is 1, 2 means we have to place a obstacle at distance 2 from the origin. Means this is 0, this is 1, 2, 3, 4, 5, 6. So we have to place a obstacle here. So let's place the obstacle. Now, second type of query is 2 comma 3 comma 3. So we have to just tell that if we can place any object of size 3 in the range 0 to 3. So if I consider the range 0 to 3 here, can we place any obstacle of size 3? Like here we have space of size 2, at most size 2, and here we have 1. So we can't place the obstacle. So answer will be no. So first this second type of query, the answer is false. For the next query, 231, we have to just tell that can we place a block of size 1 in the range 0 to 3. So if you see the range 0 to 3, we have two like clear spaces. One is of size 2 and one is 1. So yes, we can place a block of size 1. Either we can place it here or we can place it here or anywhere. Like so, the answer for this query will be yes. And for the next, can we place a block of size 2 in the range 0 to 2? If you see in the range 0 to 2, there are just one place of size 2. So yes, we can place it. So this is the problem. Like we have to just return yes or no. So what can be the idea? First, if you think this in the brute force way, like we will create a kind of vector or something. Then we will mark the index where we have to place an obstacle. And for each query of type 2, we have to just run a for loop and check if we have sufficient place or not. But if you see the constant here, the query's length is 15 into 10 to the power 4. So basically 10 to the power 5 order. And the size also can go, the x coordinate can go up to like 5 into 10 to the power 4. So if there are too many queries of type 2, if we do brute force, we won't be able to solve it. So we have to find an efficient way. So what is the task here? Like if you see carefully, we are not told to like place the block or any efficient position. We just have to return yes or no. So if anyhow I am able to find like in that range what is the maximum size of a clear block, then we can answer the problem easily. Like for 0 to 3, we can answer that we have the we have two clear places, one of size 2 and 1. But if we find the maximum size, so if a block can fit in the max, like cannot fit in the maximum, it won't be able to fit in any other empty cells. So we will just calculate the size of the maximum clear block, and then we will just calculate that like yes or no, that will we be able to place it or not. So what can be our idea for that? So our idea will be to store values like I'm creating like this line, let's say. Now we will just store the value that for from every obstacle, how many clear block are there right to him. Like let's consider a obstacle in the origin, like it doesn't matter. Uh, so initially, when there will be no query, so first we will place an obstacle here, and how many clear cells are there right to him. So there are infinite cell. So we will store the value infinite here. So now we will the next query will be to place a obstacle at like point 2. So when we will place the obstacle here, now how the value change? Like the only value that will change of the obstacle that is located left to it. So so here it will be no more infinity. It will be like the distance between the previous obstacle and the current obstacle. So that will be 2, and now this will be infinite. Yeah. S- This will be infinite. Now if I want to like make a query here like 233, so we will just go in this range, and from like 1 to 2 we will just check that how many values are there on him. Like just yeah, so that is the idea. Like we will just, and let's say there are another like query of type 1 that we have to place a block here. What we will do, we'll just find the previous obstacle of the current one. Let's say this is this one. Now we know that there are like infinitely clear block from here. So what we will do, we will just like how we can calculate the distance and the update. Like if the previous value is d, like let's say for example, like there are two obstacle already here and here, and the distance between them is like d. Here the it is stored d, and here is infinite. So now we know that we have a new update that we have to place an obstacle, like let's say here. So what will be our first task? Our first task will be to find the uh, nearest like leftmost obstacle of the current obstacle that we are going to place, uh, which is this one. Now we know that there are d like clear cell right to it. So we know that this distance is d, and we know the current position of ours current cell. So it is 4. So what will be the this distance and this distance? We have to just find the calculate these two distance, which is very easy. Like what is the distance between the previous, like the leftmost obstacle and current obstacle, is basically the difference between their coordinates, which will be in this case 4 minus 2. This is 2. So what will be the right of this, like what will be the value we will store in this current obstacle? That will be d minus 2. Now we will just update the value to from d, we will do 2 and d minus 2. So that's the idea. So if I uh, make it step by step, like for the update of type 1, what we will do, we will store the value in the place of every obstacle, that how many clear cells are there right to it. And then when a new update will come, we will just find the closest left obstacle, and then recalculate the distance, like the value we are storing of these two, like the current obstacle and the previous one. And for the type 2 query, what we will do, like let's say now, let's clear these things. Okay, so here if we update, this is like the value for first one is 2, this is also 2, and this is, let's say, d, and this is infinity. Okay, so now we know that how to, like we learned that how we will store this value and we'll update this value. Now we have to find, like try to understand how we are going to calculate the answer that type 2 queries. Like there, let's say we are told that we have to check if a block of size x or size can be placed or not. So for that, we have to just calculate what is the maximum, like clear cells are there in that range. So for that, what we will do, we can use a segment tree, and in that segment tree, we will just calculate the maximum among the values. This, if you don't know about segment tree, don't worry, like learn it afterward. Like you can take it as a black box where we can update any point, like value of the point, and we can query a range that what is the maximum or the sum, or like GCD or anything like in that range. So what we will do now, we will just take a range and we will calculate what is the maximum size of the cleared cell in that range. But there is a problem. Like if you see carefully, like let's say here and here, if the range is like from here, one second, let's clear the pictures. Yeah, here to here. If you see what is the cell size, first clear cell is size 2, second is 2, third one is D, and the next one is size 2. Because, yeah, the obstacle store infinity because there are infinitely clear cell right to it, but the range itself limited after the two cells next to this obstacle. So if we query in this way in the segment tree, it will definitely return the infinity. But if you see carefully, the answer should be uh, this should be 2, so will be maximum of these 2 to D and 2. So to solve this problem, what we will do, instead of querying in that range, we will query the range minus size, like here. Why? Because if a cell is size x or greater, the starting point of this cell will be definitely like x distance left to it. So what we will do, we will just, instead of querying the range from 0 to x, we will query 0 to x minus size. Why we are doing so? Because we are storing here the starting from point of the blocks. So clear blocks, we are storing the length of the clear box in its starts. So we will just query from this to this to check if there is enough cells, like enough size to place that block. So let's code this. Here, first we will do what we just need a map. Let's say D. What does D store? D store the length of the clear cell from an obstacle. So so initially, let's say there are an obstacle at origin, which is actually not, but we are supposing to make this problem easy. So initially, the length of the clear cell from this 0 is infinity. Now we will process the queries. So to queue queries. If it is a type 1 of query, so if q0 is 1, means we have to do some update, and otherwise we will just say yes or no. So basically place an obstacle at point x. So x is basically q1 here. So our first task is to find the left most nearest obstacle from this current obstacle. So for that, what we will do, we will query in the map itself. Like the previous point will be, like we will do a lower bound here, like d dot lower bound, and it will return like q1. It will return the equal or greater value of q1, but there is no equal value because it is guaranteed that there will be no obstacle beforehand. So it will return the greater value than q1. Now we have to just decrease the pointer to get the smaller one, which is like the biggest value, which is smaller than q1, and then it will return a iterator, which is a pair basically of key and key value pair. So we will extract the first, or otherwise you can use a set here also. Like you use a set of points, and then you will just insert points dot insert 0 because there is a obstacle at 0.0. We are just considering it, and then what we will do, you will just points dot lower bound the similar way, like of q1 and minus minus, because we are going to need the previous one. So you can do it anyway. Now after that, we know the length of the clear cell after the previous is basically d of previous, and we have to just update these two value, d of previous and d of current. Current is basically q1. So what will be the current? Uh, so the distance between current and the this will be, now we need to, this is suppose our current, we know this length. So what will be the distance between this? Okay, so first we have to calculate the distance between these two, and then we can update this. So int distance equal to basically the difference between the point, which we can calculate directly. Here we can use d of previous. So firstly we are going to store this one. So this will be total minus this distance. So total is basically nothing but d of previous minus this distance is q1 minus previous. And after that, d of previous will be nothing but q1 minus previous, q1 minus previous. So we have just update these two values. Now here I'm just not taking any extra space here. We will just get the previous from the map itself. So d dot lower bound q1, and then just go with the first, like the key. We need to find the key. So after that, we have just successfully updated the type one query, and we have to just build a segment tree also. In the segment tree part, we also like the update these two value. So for that, we will use, you can use any template of the segment tree. So I'm using the segment tree here, the range query, I think. Yeah. So let's copy this from here and paste it. So basically, this is a segment tree template taken from the AdCoder library. So if you don't know about this library, because like this is a library where some famous standard algorithms and data structures are there. It is included in the AdCoder platform also. Like if you want to submit it there, you don't need to copy this code. You just can include the header there. It is on that platform. So here we don't need these things also. We just need set and product. Like we don't need these stuffs. We can remove this or we can keep this. It doesn't matter. So we have taken the segment tree. So now we are going to update this segment tree. So first initialize this segment tree. Seg tree, the type is int, and we are going to write to functions. We need to find the maximum in that range. So maximum of int ab, we need to define this. So return if a greater than b, then we will return a, otherwise b. And we need to also use a neutral like function to initially set value of the neutral element. So for the neutral element, initially all value of the cells are 0. So we will do that as 0. So after that, we just pass these two functions here. And now we have to declare the size of the segment tree. So if you see here, the size can go up to 5 into 10 to the power 4. So let's take that thing also. Let's write it here. We need constant in infinity is 1e9 and max value is basically here 5e4. So 5e4. So the size will be some max plus 5, let's say, for some safety purpose. And now we will just update the value of this segment tree. So segment tree dot set point q1 will be d of q1, and similarly segment tree dot set point, like the previous point, will be d of previous. Okay, so I think that's all for the type 1. And for the type 2, what we can do, we can just query like bull can, like can we place obstacle. For that, what we need to do, like here we know the x is basically q1 and size is q2. So first of all, this x has to be greater or equal to this size. Otherwise, it's not possible. Like if the range is smaller than the size of the block itself, then it won't be possible to place the block here. So for that, we will just do q1 should be greater or equal to q2. And along with that, we need to find like the maximum in the range of 0 comma q1 minus q2. So it should have to be greater or equal to size. Size is q2. So here Let's write this x equal to q1 and size equal to q2. So now we know that x has to be greater than equal to of size, and this comma x minus size has to be greater than size. And here in the segment tree, this from like if we want to query from L to R, this R is not inclusive, so we have to pass plus one here. Like to query from range L to R, we have to pass L comma R plus one because the R is not inclusive for this definition. So and after that we can just push back this value to our answer dot push back this flag, and also we have to declare the answer here. Like it will be a vector of boolean, and we can return the answer. So if I run this, this should work fine. So it is some problem with the lower bound. So we have D. Okay, we are not going to do star here because we are extracting this with this pointer function. Uh, Here we are said that undeclared this D of, okay. So D of Q1. Let's declare X here, no? Q1. So now here will be the size only. And now for all Q1 we can say X to this. So set X comma D of X. Here also D of X. So that's cool. Let's run this again on the samples. Yeah, it got passed on this. Now if I remove this and submit this, let's run on the actual main all test cases. We got a wrong answer here. So let's debug what is wrong here. So there is query of type 2 1 comma 1. Like if it is possible to like put any element of, like there are no obstacle at all, but it is asking that can we place a block of size 1 at 1, and it the answer should be true, but we are returning false. Let's see why. So uh, what we are doing wrong here, let's find that. Infinity, everything is good. Firstly, we are considering that there is an obstacle at 0 which won't affect in way. After that, we are doing this segmentary thing, and here x is q1. If q0 1, then we are going to place obstacle. So what is the coordinate of the previous, like the leftmost obstacle of current one, which basically d dot lower bound of current element, which is x minus minus dot first. Yeah, it should be correct. Now d of x is nothing but d of previous, which is the total distance minus this value, which is x minus previous, and d of previous will be x minus previous. After that, we will set these two values, x comma d of x and previous comma d of previous. Yeah, that looks fine to me. And then here, the x should have to be greater or equal to size, and we will query x minus size plus 1 rod have to be greater or equal to size. So it looks correct to me, but don't know like why it is failing. So if I just debug here, like this value, I need to know what this thing is returning. So here like 0 comma x will be 1 here and size will be also 1 here. So 1 minus 1 is 0 plus 1 is 1. So we are querying in this range. Oh, we have not set this value here. Like we are placing an obstacle and also the value of at 0 is infinity, but we are not setting it here. So we have to set sgt dot set value at 0 infinity. So I think that was the mistake. Now if I run this, it should pass. Let me include this test case also and run this again. So yeah, this time it got accepted. So let's run this again on the main test cases and it should be correct. And yeah, we got accepted. So basically, this was a simple like segmentary problem uh, where we have to just do this thing. And now if you like think this problem, like what is the time complexity here? Time complexity is basically we are like doing some logarithmic operations here. So this will be like the size of the query into some log of this constant maximum factor. So log of this maximum factor, basically log of the this upper bound, what the upper bound goes into the size of the queries. So that will be the time complexity. Now, if you like think some like modification of this problem, that this coordinate is not limited to 5 into 10 to the 4. Like this coordinate can go up to really higher values, like from 10 to the power 16 or 10 to the power 18 order. Then you have to take this max as 10 to the power 18 or 10 to the power 16 order, but that is not possible because you can't create a vector or any data structure of that large size. So what you can do then? Then there is a technique you can use, that is the value compression. You know that the query's length is limited because they can't basically provide you the queries in such long vector, but they can extend the limit, the range of the point in far away. So in that case, you can compress the given values to a smaller range, and then you can build a segment on top of that. So how you can do that? Like if you have like something two values of let's say one E16 comma one E18. So you have only two values, but they are very large, like in higher order. So for that, you need to have to create a segment tree of 10 to the power 18 like size, which is not possible. So what we will do, we will compress the value and we will assign like one E16 as 0 and one E18 as 1. So basically here this value, the we are just compressing them and we are giving an ID to these values, and we will use this ID to update and query in the segment tree. And this ID will be very small range because any like you can, if you have the query of size q, and there can be at most of q size of ID because there can at most q unique elements there. So for that, what we will do, we will just write a compress function, compress queries. So basically, this compression technique needed only if the this is some harder version or like the range is high, really high. So what we will do, we will take a vector. So what is the idea there of the compression? Like let's say you have some value of 20, comma 30, comma 31, something, 50. So first basically we will collect all the values we are given, then we will sort them, and then we will assign them the ID as 0, 1, 2, like simultaneously. Like so we will sort them and the index of that element will be the ID of that element. So we'll take a vector there of ID. Now we have a function of compressed. We'll pass this vector here. Let's pass this as constant data type. Now for auto query. If the query type of one, q1 is 1, so then this q0 will act as a point. Like we have to just compress the value of the coordinate we are storing or accessing from the segment tree, because we want to reduce the dimension of the segment tree by compressing value. So if you see carefully what we are storing and querying in the segment tree, this point x, the point x we are storing there, and also we are querying this x minus I plus 1 or something, x minus I. So we can just keep those value. So we will just push the id here, push back this q1, because we need this q1 in compressed form. And for type 2, we don't need q1. If you see carefully in the type 2, we are not querying x anywhere in the segment. Instead, we are querying this x minus I or x minus I plus 1, anything will work. So let's push this as x minus size instead, like q1 minus q2. Then we will just sort the values of id, and we will erase, like make this unique. Like we'll remove all the duplicates. So id dot erase unique id dot begin comma id dot end. So what this unique function do? Unique function will uh, like transfer all the unique element towards the left side and all the duplicate to the right, and then it will return a pointer from like which the like up to which the all the unique elements are there. After that, they are all duplicate. So we will erase from that point to id dot end. So after this, id basically compressed. So that's all in the compression. Now, if I want to get the id, so if I need to get id of any point of x, what we will do, we will just return the index of this of the value, and these value are in the sorted format. So we can just do a binary search and return this. So we will return the lower bound of the point x in the vector id minus id dot begin. Basically, we are returning the index of that value. So here we will do what like the id of the 0 will be 0. We have to push this in the compression also. In the compression, we will push id dot pushback 0. Okay. So now this will be infinity. Here this will be like infinity. Everything is okay. What we will do, we will just instead of like inserting this in the segmentary direct, we will just get their id. Get id of x. Now this size will be the id dot size basically, because what is the limit of this id dot size? The id size can go up to q only, like the query's length, which is limited up to this. Now if this value go up to 10 to the power 18 or something, it doesn't matter, because we always need the, like we are compressing the value in this format. So after that, we'll just get id of this and also convert the values into the id. And similarly here, also retrieving the value, we will just convert the value into id. And if I run this, this should like work correctly. Yeah. So if you see, it should pass in all the samples. It got wrong answer. Mm, let's check, like debug why this happened. So we have ID size, everything is good. We are compressing all the IDs. Okay, we are going to like if Q1 is less than Q2, then we are not going to push this here. If this is only valid, then we are going to push this because why the problem is happening if you see carefully, like if this Q1 is greater or like less than Q2, there will be some negative value. And if we are pushing some negative value in the ID, this zero will, the ID of the zero won't be zero. So in that case, either we can omit the negative values, then if I run this, it will pass, like will work correctly, and it should like let's run this. Why this is taking so much time? Uh, I think some internet issue. And otherwise, what you can do, you can just simply do this here. Like you can get ID of zero. Then you don't need to like this thing because we are not passing the ID here. We are passing zero instead. So then we are considering that ID of zero is zero. But if we have so much negative values in the ID, then this will only be zero. So anything will work. Like if I don't want to do it here, then we have to pass this as a get ID of zero. And now if I run this, it should work fine. So yeah, now if I submit this, it should be accepted. Yeah, it got accepted. So what is the time complexity now? Time complexity is basically we're processing total queries. So if the size of the query is q, so q, so time complexity is q order of q into there are two type of query. One is basically we're querying in the segment tree of size q. So it will be log q, something order of log q, logarithmic of q. And here also we're doing some logarithmic of at most size q because this d map can also be of size q at most and the segment tree can also. So it will be overall q log q size, which is good in this case. And if you see the space complexity here, will be this segment tree text like the linear space. So will be of space q, and this map also store linear space. So space complexity will be like order of q. So that's all for today. Let me know in the comment like in which method have you done solve these. Like do you know about the value compression before? Like this is a very good technique. Like in some of the harder version of this problem, there are some ranges might be bigger, which you can't like process directly. Then you have to this compress the values, and also in some problem you need to be decompress this value again. So that's all for today. But like for this problem, like as the range is limited, you can just hard code this or take this as a maximum, and you can build the segment tree on top of that. So that's all for today. Thank you.